Now then, Steve Tonkin, a well-known name in astronomy. I'm sure you know if you read this BBC Sky at Night magazine. I've got an extract here from his Gravitar profile, something, as I've already told him, I'd never seen the likes of previously, entitled Binocular Sky. Now, there is a line then that says between the New Forest and Cranbourne Chase, which I'm assuming is your neck of the woods, Steve?
It is indeed. Yeah, my wife loves the New Forest. I love Cranbourne Chase. So we live.
So you live in two houses?
No.
So you have two addresses?
Same house, same house. Just a lot of walking.
They're good. So, Steve first tried the use of binoculars for astronomy in 1957 when his father took him outside to see if he could spot Sputnik. He was hooked. In 2011, he started the Binocular Sky website to promote this aspect of astronomy. This led to him being invited to write a monthly binocular tour for BBC Sky at Night magazine, which, as I say, I'm sure we've all seen, from which he also writes equipment reviews and articles on practical astronomy. He also teaches astronomy courses, is a STEM ambassador, and does practical astronomy outreach with people of all ages, and is a speaker on the UK Astronomy Society circuit. His talk tonight is titled Two Eyes Are Better Than One. So please welcome, in the Mexborough and Swinton Astronomy Society, welcome, Mr. Steve Tonkin.
Thank you very much. Thank you. Okay. Well, again, thank you for inviting me. It's been a couple of years since I was physically up that way. And I have to say, I really enjoyed it when I was up there before. What I plan to do this evening is go through why bother with binoculars for astronomy. If you are going to bother with them, what should you get, how you should use them, and what you should look at. And somewhere in there, there will be things like what to avoid. I'll be flipping a bit between what you see now and a PowerPoint presentation. So let's see if we can get this working and kick off. Excellent. Okay, so let's kick off as I said we would. And why bother with binoculars? And there's any number of reasons. The ones that I think are important is because, first of all, they're an excellent beginner's instrument. It's something most of us are told when we're starting out in astronomy, is start with binoculars. Quite often nobody tells us how to do that and explain why, but it's certainly there. And why it is we'll come to in a moment. But they're also an excellent serious instrument. So it doesn't really matter where you are in your visual astronomy career, as it were, you will always find there is some sort of binocular that will suit you, because they're incredibly portable, particularly in the small sizes, but even my big binos, I can set up in 10 minutes and can't anywhere. So they're so easy to set up. And if we're thinking about things like handheld binoculars, how long does it take? Take them out of the case, put the strap around your neck and bring them up to your eyes. You know, it's really quite important. And I remember some of the weather we've been having for the last few years. You know, I'd be out with mates in the New Forest where we do a fair bit of observing, and more recently Cranbourne Chase, since it's now been declared a dark sky reserve. And where, you know, friends with equatorial mounted stuff, you know, they'll be setting up and, you know, sort of half an hour, 3/4 of an hour later, they'll just about be there, you know, cameras all done and everything like that. And the clouds come over or the rain starts coming down, and I've already been observing for 3/4 of an hour. So I win, I guess. So that's the easy setup. And then you get what's called the binocular advantage, which, you know, people say, well, what's the binocular advantage? And it's essentially, what you need to remember, it's times 1.4. And what it means is that if you are observing with, say, 50mm binoculars, and we're thinking of looking for faint stuff. So we're looking for stuff at the edge of visibility. You will be able to detect approximately the same as you can with a single telescope, an aperture 1.4 times that. So a 70mm telescope will give you the same sort of detection as a 50mm binocular, or obviously vice versa, or 100mm telescope for a 70mm binocular, and so on. So there's certainly part of that. And this is due to a couple of things. One, you get statistical summation, which is essentially that you have, if you're using two detectors, again, this is really only applies to very faint stuff, you improve your probability of detection, because once we're dark adapted, our retinas can be triggered by single photons, which is quite useful. And then there's what's called physiological summation, and that is essentially, for the images amongst you, it's stacking. We have two channels, and basically you cancel out neural noise. And so you get an improved signal to noise ratio. And you can try this quite easily for yourself. If you look at something, say a page in a book, and you take it further and further away, so you can just see what it is with two eyes, and you close your less dominant eye, because why not observe with your dominant eye, and you'll see that all of a sudden the thing that you could see, just make out, suddenly you can't anymore. And this is just part of us evolving with two eyes. So, you know, we are two-eyed beings. To my mind, it makes sense to make use of them both. And also you get things like false stereopsis. Now, obviously it's impossible that something, you know, sort of tens of light years away or millions of light years away is going to show any sort of stereopsis, any 3D vision at all, but it looks like it does. And quite honestly, with visual observing, if it doesn't look attractive, you know, I like it looking attractive. It's fun, it's enjoyable. And there's some suggestion, although I've never seen actual evidence for this and certainly not experienced it, that if you're using two eyes, you can negate the blind spot. I think the probability of your target being on your blind spot is pretty small, but of course it can exist. But if you're using two eyes, it cannot fall on the blind spot of both eyes simultaneously. So that's good. So that's sort of my idea of why we should bother to use them. Basically, they're convenient and they are pretty blooming good. Okay, common types of binocular, I divide them into three really, and one is a bit contrived, but I think for astronomy it certainly works. So there's poroprism binoculars, roof prism binoculars, and things with angled eyepieces, which are usually a combination of the two. Okay, so poros, you've all seen, they're these things here. This is a cutaway of one, and you can see here the light path through the prism. You get one prism, well, as you know, with an astronomical telescope, if you don't do anything to the light that goes through it, you just use a normal Keplerian or other type of positive eyepiece, the result of what you get would be an image that's back to front and inverted, upside down. And each of these two prisms, one of them will invert it, sorry, we have gone back one too far here. Go, right. So one prism will turn it the right way up and the other prism will turn it the right way round. And so we get a normal image. So that's your light path. The other nice thing about this, you can see here, your light path is folded. So that means the instrument becomes shorter, which means it's less unwieldy, easier to hold. If you're going to mount them, easier to mount, captures the wind less, and so on. Okay. The advantages is they, within a given price range, they are generally, and this is becoming less so now that manufacturing techniques are improving, as they still are, they're generally the best quality in a given price range. Some people will say, you know, we refer to poroprism binoculars nowadays as astronomical binoculars. And the other good thing is they're relatively easy to maintain. This becomes important if you get a budget model because they do need a bit of maintenance. Disadvantages is they're bulkier and heavier than the roof prism ones, And the cheap ones really, really easily lose collimation. That means that the images you get through each tube stop lining up, so you get a double image. If it's only slight, it's you might not notice it, but you might find that it makes you feel nauseous, or you get headaches observing or something like that. If it's really bad, you'll notice it and you just know you've got two images. And that's why you need to be able to maintain them. Roofs, on the other hand, are what a lot of people call birding binoculars. Is that sort of thing. The prism here, again, is sort of folding the light path, not quite as much. And this prism here, one of them has a roof on it, as it were. So the light bounces both ways off the roof and then recombines, which introduces problems because you get out of phase recombination, which reduces your contrast. So you put coatings on for that. But what it makes for is what's essentially a straight through design. It's also, you have internal focusing on it. And that means the whole thing's lighter, it's more compact than Poros, much easier to waterproof because your focusing is internal, but they are more expensive. And that's largely because that roof prism has to be manufactured to 90 times the precision of a Poro. So and precision costs money. And they're much, much more difficult to self-maintain. There are some people who do nowadays. Frankly, I don't bother. I will send them to somebody who can do it better than I can. And the other thing is, of course, your aperture is limited by what is effectively a straight-through design. If your eyes are, say, your eye pupils are, say, 65 millimeters apart, your tubes can't be bigger than 65 millimeters in diameter. So you can't get big roof prisms unless you start playing around with them, which effectively means adding more glass. And if you're adding more glass, you're either going to degrade the image, you will degrade the image anyway, but you're certainly going to add a lot of expense to it. And then we take the angled eyepiece ones. This is my favorite one, my favorite binocular. And this is really, really nice to use. You've got much, much more comfortable to use. You don't have to crane your neck at high elevations, which is nice, but they are much more expensive than straight through binoculars. And that's because you're putting that extra bit of glass in there that diverts the image through 45 degrees. And unless it's very good glass, it's going to really degrade your image. And they also have to be mounted. Normal way of looking at an object in a straight through binocular, whether it's terrestrial or astronomical, the best way to do it is you look at the object and you shove the binoculars in the way. And with astronomy, if you can't see it, you're probably too low. So, you know, high altitude stuff, we do tend to look a bit lower than things actually are. So you're probably a bit low, so you just go up. But with something that's got angled eyepieces, you can't do that. So you do need some sort of mounting, and you need some sort of finder scope on it as well. So once you start complicating it, things start getting more expensive as you get bigger, less portable, less time to set up. But I'll show you a picture of that big bino on the mount I use on most of the time, and that is something I can set up in 10 minutes, largely because I'm used to doing it. Right, so what do you want? Binoculars, I'm sure most people know, are described by two numbers. It's one number times another number, and that's magnification times aperture. Now, magnification is essentially diameters that you're magnifying. So we take something like an 8x40, usually favored by birders, that sort of size. They can very, very easily be handheld steadily. And that's pretty important to be able to do that. But for astronomy, quite often, we're not really looking for exquisite detail as birders might be doing. We're more looking to be able to detect. And 10x50, most people can handhold. When my son was 8 years old, I'd given him his 10x50s. I showed him how to use them and all the rest of it. And we were in the garden one night, and he said, "Dad, I've found something." And he devised a star hop to show me what he'd got. And he'd made a completely independent discovery of the cluster M34. So if an 8-year-old can handhold 10 by 50s and do something like that, I reckon most people can probably be taught to, and they're certainly not, it's certainly not too much for most people. Once you get on to something like 15 by 70s, which are become very, very common, especially since the Chinese introduced them about 20 odd years ago, budget ones, they can be handheld for brief periods, but you'd actually see a heck of a lot more when they're mounted. That said, I was out comet hunting with 16 by 70s in the early hours of this morning, Comet Swan, and I was doing it with handheld 16 by 70s. I didn't find the comet, and I found out this afternoon why. The comet has now just disintegrated. It started to disintegrate. So anybody who's hoping for a nice bright comet swan over the next few days, sorry folks, the imaging shows that it's on the way out. It didn't really survive perihelion. And then you get bigger ones like 25 by 100s or bigger than that, and they have to be mounted. You really can't hold those and see anything for more than a few seconds at a time. So what size do you want? What I'm going to show you is, first of all, what different sizes will show you. This is my sort of semi-rural, semi-suburban area, and that's the cluster M35 in there, the M35, which is in Gemini, not in the sky at the moment easily. Okay, so with 10 by 50s, I see something about like that. With 15 by 70s, there's two things that happen. One is the cluster looks bigger, but secondly, I'm also getting slightly more contrast. Sky dark background's gone darker, and then when I put my big brutes on it, I get something like that. And there's actually quite a lot of difference between the two, but it's size isn't everything. Your conditions are really important. Light pollution makes a difference. So if we again take those two, just the two extremes of that, 10 by 50 and the 15 by 70, if I head down into Bournemouth, that's about what I'd see in the 10 by 50, and in the 37 by 100s, that's what I'd see there. So when I do outreach at schools in Bournemouth, shall we say it's a challenge. But we manage, and I've got a dozen sets of 8 by 42s, which I let the kids use, you know, hand them out, and so they can just have fun trying to find stuff, and they see stuff. However, you go up somewhere really dark, like Loch Loyal, or even better, where I grew up, which is in what is now Zimbabwe. You get away from the cities, or in Zimbabwe you don't need to now, because it's like North Korea. There's power cuts all the time, so you don't get a lot of nightlight bothering you. This is the sort of detail you can get. Light pollution really, really makes a difference, as I'm sure we all know from any visual astronomy, but with binoculars, you really, really do notice the difference. From my reasonably good skies in my back garden, if I just go a few miles west to Cranbourne Chase, where the Dark Sky Reserve now is, boy, I see so much more, and it's so much more enjoyable. Okay, hand holding them. You can try this. Take the top joint of your thumb, that is that one there that I'm indicating on the screen, and you will find that it fits perfectly in the corner of your eye, which is, it's extremely comfortable. And instead of holding the binoculars as people usually do, which is around the prism housings, if you have a couple of fingers around the eyepiece, a couple of fingers around the prism housing, and your thumbs in the corner of your eye, so it's like you're shielding your eyes from either side, you suddenly find it's much, much more stable. Number of reasons for that is, one is you are creating essentially a triangle, and I think we all know triangles are stable things. But secondly, the higher you look, the more the weight is taken on your head and less of it's taken on your arms. And once your arms get higher than your heart, you can try this for yourself. They start aching more and they shake more and all the rest of it. American military teach to hold binoculars by holding them around the objective ends. And the reason that's great if you're looking at something on the level, at terrestrial stuff. But for the sky, what you really want to do is take as much weight as you can off your arms, and if you're reclined with your head supported or something like that, that's even better. So there's a lot you can do like that. Just try it out. Once you get the hang of it and you lose the fear of dropping the thing, which I have to say I have never done doing that, I think you'll find it's much more stable for high altitude stuff. If you find it worse, please let me know. Right, tripod mounting. So this is some 15 by 70s. These are the Helios Apollo ones, heavy brutes they are, and a trigger grip head, which I find most useful. But look what's happens once you start getting tripod. You've got 5 legs, essentially in a territorial dispute, and it can be a real pain in the butt sometimes. And also, once you're getting and trying to get in there like that, you know, you start getting a stiff neck. It's really actually very difficult to observe anything more than about 45 degrees high using a tripod. You really need something that's going to take the binocular away from the tripod. And of course, however you set, whatever you're using here, as you get higher and higher and higher, this gets more and more angled out there. Your turning moment changes, and you can, if you're not being careful, you have something which is nice and easy to operate when it's up there, and all of a sudden it gets to about, you're looking at about 60 degrees, and all of a sudden it just falls or something like that, and you bash yourself on the nose and tears come and all the rest of it. So I really don't like using tripods and trigger grip heads like that. I do sometimes if I'm looking for horizon phenomena, and it's also obviously useful for sharing. So noctilucent clouds, yeah. The comet, if I'd found it, yeah, I'd have done that, and planets and that close to the horizon. So, but apart from that, no, I really don't enjoy them. What's much better, something I found out in one of Patrick Moore's books actually years ago. He recommended something called a Neckpod, which is a silly name because it doesn't actually sit on your neck and it's not blah blah blah. But what it is essentially it's a stalk here with adjusters on it. It hangs on a strap around your neck. And it's certainly better than hand holding. These are lightweight 15, the budget 15 by 70s on there. It's better than hand holding. And you can recline on it and that, but the higher you look, the higher the binoculars have to go. So you do have to keep adjusting this joint here, and eventually you'll find it loosens through lots and lots of use. And that's important with just about anything where you have to keep adjusting the height, such as a monopod. So this cheap 7-day shop one, which is the thing I was trying it out with, was great for about a year. And then when I put the binocular, it just sunk because the clamps on it weren't adjustable. So replaced it with a decent one. It's got adjustable clamps. So as they slacken off after about a year, I can just tweak them a bit tighter. So that's a little bit better than that. But it's a really convenient way of observing. It doesn't add a heck of a lot to your bulk and what you're carrying around. It really steadies it a lot. And it doesn't even have to be vertical. I discovered my wife came home from work one day and I was sitting with a soldering iron and burning a hole right between where my legs would be on my favorite garden recliner. What are you doing? Oh, it's astronomy, dear. That's all right then. So I can put the monopod down there and have it. And nope, I found out after having done that it's no more steady than having the monopod going slightly down to the side. So still okay. It's still a nice favorite recliner, but it's got an unfortunate hole in it now. But never mind, it still works. But I find this really, really convenient. And the trigger grip head is one that is really, really adaptable as well. This particular one is the ubiquitous Chinese thing. The manual for it is, well, if you get any instructions with it at all, absolutely atrocious. So I've written a decent one and I've put on my website. So if you get one of those, read the manual first, because there's mistakes people make which you might not want to have to do, like finding it stiff so they lubricate the ball. That's it, that's gone. You have to dismantle it to clean that up. You don't lubricate the things at all. Better than this actually, but they're not made anymore, but you can still get them good nick secondhand, are the Manfrotto 222 ones. They are delightful to use. They're much more adjustable and they don't need tightening up every 4 months or something like that. So that's monopods. I think they're great for medium-sized binoculars. But the parallelogram mount, which is what we've got here, this is the big binos on it. See, it holds you away from the tripod so you don't have the confusion of legs. And something like this, I can look all round in the sky. Let's just demonstrate at daytime. You see there, it's got the sight on it. So Rigel quick finder. And it's a really, really lovely thing to use. And the nice thing about this is not only is it nice for one person to use, you can change the height and the binoculars are still pointing at the same object. So when I do outreach, if I put stuff on a parallelogram, here's another one, I can find something and then just drop the parallelogram and show it to youngsters and they can see it. And this is essentially the same evening. The parallelogram set, the tripod setup is the same height. I can either observe standing here or I can observe reclined here. And it's needs a slightly longer arm than the previous one to be able to do that. But this is nice. This is luxurious observing. It's not the most luxurious observing with binoculars, but it's not a long way from it. You don't have to go to this sort of extreme. You can do much simpler things. You can use bits of garden furniture, for example, just to support your elbows or support your hands, or a swivel chair. Hey, how convenient is that? That's the recliner with a hole in by the middle, by the way. Or you can use something like a £4 window cleaner device here. Now this is the deluxe version here. You've got height adjustable there. You've got a crank top, so the upright bit can clear astronomer's beer belly there. So it's, you know, it's a useful bit of kit. You just bungee the binoculars onto the end of it. It makes a difference. Or you can go to the other extreme. This is a thing called a star chair. Binoculars I would love to have. Those are the big Fujinon 6-inch aperture things. The things that Yuji Hyakutake discovered his comet with. If you remember Comet Hyakutake just before Hale-Bopp. And essentially the joystick here will just take you to anywhere in the sky. You can fit something like Argo Navis to it and dial it in, and it just takes you around wherever you want to go. Basically, what you've got is you've got a computerized mount that you sit on. So pretty impressive. I don't know how much they are now. They used to be about $3.5 grand, but when you're dealing with, you know, sort of 12 grand binoculars, you know, mounting them properly does become, you know, you don't want to waste the binocular by not mounting them properly, put it that way. So if you can afford those, you can probably afford that. I don't. Dew becomes a problem. Once you've got mounted binoculars, they will start to dew up because they're pointing upwards the whole time, and you almost certainly won't try to, you know, remember to cap them every time or anything like that. Handheld, spending about half the time hanging around your neck pointing downwards, so they don't dew up so badly. The dew shield here is part of my wife's yoga mat. When she came home and found me cutting it up, she had a little bit of a frisson, and I showed her I'd actually got her a much better one, because of this, which is a really cheap and nasty thing that she got for herself, is actually really good for dew shields. It's a light foam, it rolls up nice and easily. Another one here for the Rigel quick finder. This one I've left vertical for 9 hours in the dark, and the little window up there, which is usually a pretty good dew detector, not as good as a Telrad, but not bad, had not a trace of dew on it at all on a pretty wet night. And nothing, as you probably discovered when you leave telescopes out and all the rest of it, or refractors or Schmidt-Cassegrains or anything like that, not newts. Nothing has a long enough dew shield on it, so you just extend that a bit. I did try using sticky back Velcro. It comes off when it gets wet, so you stitch it on. If you're going to stitch it on, it's sticky back, so it'll glue up the hole in your needle, in your sewing machine needle. So use the old kite maker's trick, which is you oil the needle every 6 inches or so, and then the glue doesn't stick to it, and you can keep on going, and you don't get a needle eye full of glue that then snaps your thread. Okay, so that's dew protection becomes important once you're mounted. Right, let's look at focusing mechanisms. Most people are familiar with binoculars that have center focus, and one of the problems with this is the bridge, particularly on cheap budget options, the bridge rocks. And because the moving of the eyepiece is what gives you focus, if you put it to your eye and your eye starts moving the eyepiece and differentially or anything like that, you're going to go out of focus. It's a pain. You've also, because the way those slide in there, you've automatically got somewhere moisture can get in. And because we're observing in the dew, we don't want moisture in our binoculars. It's really horrible. It starts doing horrible things to the inside, to both the mechanical and the optical bits. You get fungus and algae on your optics, and you get corrosion on mechanical stuff. Individual eyepiece focusing, on the other hand, not very convenient for daytime use when you're constantly refocusing, but for astronomy, we're just focused at the same distance the whole time anyway. And it makes it much easier to waterproof the whole thing. And also you don't get this rocking bridge phenomenon. So it's generally better. Most people say, go for it if you can. Well, what else should you go for? Well, internet advice usually comes up like this. I don't know how many times I've seen this phrase or something like it. As long as you get binoculars with back 4 prisms and fully multi-coated optics, you can't go far wrong. Yes, you blooming can, and we'll see why. This is a set of binoculars that I had some years ago, and the two in the middle are two that are made in exactly the same factory, United Optics in Kunming in China. And let's look what they say on the cover plates. This is broadband fully multi-coated. This one is fully broadband multi-coated. Are they the same? Well, we'll find out. 15 by 70, 15 by 70. Back 4 prism, back 4 prism. Notice slight difference in the writing. That sort of becomes important in a bit. And so made in the same factory, seem to be the same sort of specification. How different can they be? Well, quite a lot, actually. Let's clear up this thing about back 4 prisms. Back 4 prism, it's a high index glass. Now, if you have what people say horrible things about, which is BK7 prisms, which you've got here, you notice I've had to take this at an angle to get them. You've got little grey cutoffs, and that's because not all the light is internally reflected. The stuff around the edge doesn't get totally internally reflected. But the thing is, we're interested mostly in what's in the middle of the field of view. And it's really not that difficult for any of us, if something's at the edge where it's getting a bit dimmer, just to sort of shift the thing so it's in the middle. So it's not really a bad thing. And if you take something like bino viewers, the world's best bino viewers, which I think are Denkmeyer ones, guess what glass they use? This, for reasons that will become up in a moment. But with back 4 prisms, which should stand for barium crown 4, this is borosilicate crown, by the way, you don't get those grey cutoffs, but you do get something else. Look at the poor stray light control here. So that's got nothing to do with the prisms, it's just to do with the binocular manufacture. I'd actually prefer to have these than these, because this is going to give me more contrast, because I haven't got this gubbins around here reducing it. So back 4 prisms reflect more light, but they've got worse transmission and worse dispersion properties if they're done properly. But the thing is, Chinese back 4, which is here, it's got a refractive index between the two. Its dispersion is between the two, but it's not even a barium crown glass. It's a phosphate crown glass. They've just given back 4 to. They've just given it, it's like a trade name. It doesn't actually mean anything. Schott AG, the German glass manufacturer, that stands for barium crown. This doesn't, because it's not even a barium crown. And it's really, really cheap to produce. It's got a much higher what's called bubble count. Any glass is never going to be pure. and you're allowed 100 times the amount of junk in the glass with this one as you are in this one. And that reduces your contrast enormously. And you could try that. It's best to try it actually on a nice sunny day like we've been certainly having down here recently. Look at colourful flowers, and they look less colourful in a binocular that uses this than in a binocular that uses this. And it's all due to the gunge and the prisms. Right, much more important is how your prisms are held in. This is a proper prism cage. So the prisms are actually held in, they're bolted in the cage. You can collimate them there. This is really nice. There's a groove prism here, which reduces spurious reflections. See the groove a little bit better there. Taking the cage out of the binocular there. That's nice. Cheap budget binoculars, you get a clip that holds the prism in place. If you're lucky, it's screwed in at one end. Sometimes they're not. And we also have here the prism can be adjusted with a screw on the side when it does go out. This is the thing we were talking about earlier, about it being easy to go out of collimation. Once that prism shifts, you get a double image. And self-maintain, learn how to put it back. It's not incredibly difficult to do, but all your air glass surfaces, that includes the prism hypotenuses, have 7-layer anti-reflective coatings. And that is obviously different. These are our two binoculars made in the same factory, made supposedly with all the same thing about it. You can tell, I think, just by looking here, which one is chucking back the most light. It's this one up here, and of course that is the budget one, that's the cheap one. So I think we can safely say fully broadband multicoated and back four prisms really don't necessarily tell you much about what you want to know. So what about the 15 by 70? So set up on my kitchen, laser pen with a beam broadener, and I'll find a scope because laser beam broadeners are expensive, going through binoculars. So this is giving you a collimated beam of light into here, into the eyepiece, so that what you get out here is, because optics are reversible, is equivalent to what you get going the other way. Now, a bit difficult to see on that, but this measures 62 millimeters here. So effectively, what's happening is something in here is cutting down the aperture from 17 millimeters to 62 millimeters. Now, another way of doing this, you can just tell this is graph paper here, not with the sun, but at a bright sky. Just hold a piece of graph paper behind your eyepiece and move it backwards and forwards so you get the sharpest image you can. And that is your exit pupil, that goes in your eyes. You multiply that by the magnification binoculars, and it will give you the true aperture. Rather than faffing about with lasers, you can do the same with a torch. I'll show you that in a bit. And I'll also show you how it gets stopped down. You could say you can test stuff in a shop or something like that with your phone flashlight. So laser gave me 62, an LED torch gave me 62.5, and exit pupil gave me just over 60. The point is it's not 70. So to my mind, that's fraud, because it is not a 15 by 70. It's a 15 by 62. The reason they do it is because the rays of light that are most mess up your image if you haven't got decent optics are the ones around the outside. So they just chop them off. And so I'll show you in a bit how they actually do that. Don't bother writing all this stuff down. I will send the club a PDF of this, and you can, so if anybody who wants it can have it. These are things which I think are much, much more important that you don't get from anything that's written on the cover plate. There's a heck of a lot here. So what's the prisms are correct size, black and size, all the rest of it. Your coatings. Now, nobody's going to, be able to tell that. So really what it comes down to is that really the only way to tell if binoculars are any good is to go outside under a dark night, dark sky, and shove them up to your head and see if they are or not. That's really the only way you can do it. It's almost impossible to do it sensibly in any other way. So that's sort of on what to get, but what to avoid. What I call BSOs. Let's have a look Can you see me now?
You can. We can see you.
Excellent. Good. So let's have a look at what BSOs are. These are BSOs. This is a binocular shaped object. Okay. It is a this I got. I was giving a talk somewhere, and somebody came to me and said, "I've got lots of binoculars that my husband bought before he died. Do you want them?" So I thought, oh, my mate Bob Myson could sell those for the Commission for Dark Skies. Went along, and this was amongst them. I said, "Why has he got so many?" He said, "Well, he kept buying them and then say, well, that one's failed," and carried on. So this is a binocular shaped object. It's got various things you can look out for. It's got zoom. There is no such thing as a good zoom binocular. My old friend Bill Cook, American binocular repairer, I once said there was no such thing as a good binocular for astronomy, and he just said, "No, Steve, you got that wrong. The for astronomy is absolutely redundant." So zoom is one thing. The other thing it's got, you can see there, it's got the latest ruby coatings. Now let's look at what binocular coatings or lens coatings are actually for. This is another binocular. It's got a tiny little thing. This is one of these little 2.1 by 42 Vixens. And the coatings on that are pretty blooming good. So what we'll do is we'll use the ceiling as a screen, and we'll see what binocular coatings are for. So let's hope I can get this in the right place. As you can see from here, this is a pretty bright torch. You can see from here, I'm getting minimal reflection. I mean, this torch is going to reflect anyway, but this is decent coatings. So that's anti-reflective coatings. Let's have a look at the latest ruby coatings. Can you see the difference?
Yes.
Yeah. It's not showing so well on the screen, but this is a nice red color here. So why do they do it? Well, the answer is quite simple. They do it because it saves them having to do proper color correction to the binocular. You get rid of the red end of the spectrum, you don't have to fix it with glass. So that's one of the obnoxious things about this. So what that means is you look through this thing and the whole red end has gone anyway. It's sort of like the entire universe has undergone a zombie apocalypse. And the other thing I was saying about what happens when you shine a light through the thing. So that's a, we don't need. And you should be able to see there. Now that is not 70 millimeters. You measure that and you will find that is 50 millimeters. This is actually stopped down, so it's effectively a 50 millimeter binocular. And the way they do it, and this happens with a lot of budget stuff, is down here. In here, there's a little diaphragm at the entrance to the prisms, which like very, very bright torch. Don't want to over illuminate it. You should be able to see that there. You can see how there's a ring that cuts off the light. And that's what they do. So this 80 quid binocular, which I hasten to say does not have a manufacturer's name on it. And well, don't blame them. Would you want your name on it? Is a 12 to 60 times 50, not the 70 it says. It's got rubbish coatings. It doesn't focus properly. The entire world looks like a dodgy movie that's undergone a zombie apocalypse. And in addition, though, one nice thing you get about it, you get 2 images for the price of 1, because it is impossible to merge the images on one of these. So that's that load of rubbish there. Well, I've got this out. I'll just mention this little thing I've got here. It looks a bit weird. It's called a Bino Bandit, and it sits up around there. What it does, take the thing off, it sits over your eyepieces, It's called a Bino band because it looks like a Zorro mask or something. And it shields from the side, it cuts out the light, and I think I love the things. I've put them on all my binoculars now, and they really give you a much more immersive feel and all the rest of it. Now, I don't get a commission for saying that, I just like them. So that's the good old Bino Bandit. Useful bit of kit. Anybody who's seriously looking for faint stuff really need one. Okay, we'll go back to the screen share. Yeah, right. So that's those. So
Okay, we're back with the screen share.
we are. So zoom, avoid. Ruby coatings, avoid. The other thing to avoid are focus-free binoculars. They're not actually focus. What they do is they fix focus, and they set up what's called the hyperfocal distance, so your eyes have to do the focusing. They're sort of acceptable for, you know, sort of really entry level binoculars for terrestrial stuff. They're terrible for astronomy. Quick focus, things like the Tasco Zip, where you've got about a quarter of a turn of the focus wheel from whatever its close focus is to the other side of infinity. It's impossible to get the thing very, very finely focused. So those are other things to avoid. So what we've got there, we've got binoculars we want. What do we look at? And there's loads of stuff we can see. I'm not talking about planets and that, because really binoculars aren't your best. You know, planets and moon, let's be honest, telescopes tend to be better on that. So galaxies, large galaxy, that's M31 from a dark sight through 10 by 50 binoculars. And you can see so much on here. You can pick it up. Well, you can certainly see the cores differentiated, but can you see the cutoff on this side is more abrupt than the cutoff on this side? Just detected the dust lane. And this is the sort of thing that you can see with 10 by 50s from a dark sky. Something like M33, again, dark sight, that's about as much as you'll see of it. It's a pretty small thing. Planetary nebula. I had some planetary nebula, and it's a very small value of some. That little thing there is the biggest planetary nebula we can see. That is the Dumbbell Nebula, or the Apple Core Nebula, the Diabolo, whatever you want to call it, in Vulpecula. And you can just about make out in 10 by 50s that it's elongated. You've got this little, it's relatively bright, little glowing cloud there, but it is just elongated. Planetary nebulae are not your best targets, shall we say. Globular clusters, it's about as much as you see of M13. Don't expect in 10 by 50 to start resolving any stars. But once you get onto asterisms, pictures in the sky, this is Kemble's Cascade. In autumn's the best time for this, autumn evenings, because this is vertical. And it looks like a little ribbon waterfall here, falling into a splash pool. It's a little cluster at the bottom, NGC 1502. It just looks delightful. Or first time I saw this when I came to England, my friend Bob Meisen showed it to me. Showed it to me as a wristwatch. There's the strap and there's the watch in the middle. It was discovered by Father Lucian Kemble, who was lived in Alberta in Canada, and he got it with 7 by 35 binoculars. The end of the 1970s, and just showed everybody he could this thing. So it's got his name. You could discover something as well. Eddie Carpenter, who is a lovely old gentleman with the Cotswold Astronomical Society, has spent decades showing people this, which we now call Eddie's coaster. We've sort of had it officially recognized. And Eddie's coaster is basically, it's this little roller coaster of stars here. And it's not apparent on star maps or star charts, but it jumps out at you in 10 by 50 binoculars. This is the middle star of the W of Cassiopeia here, Navi, I think they call it nowadays. And so in your 10 by, get that at the bottom of the view, and this thing just goes across there, Eddie's coaster. So look, you can look around for stuff and find stuff. I've found enormous amounts of stuff that some of it people have found before, some of it people haven't found before. And, you know, some of the, yeah, okay, this is pareidolia, isn't it? You know, you're sort of making up pictures from where there's just randomness, but it's enjoyable, and binoculars are really good for that. This is one, it's our favorite summer star party piece for a lot of people. This is Colander 399, or Al-Sufi's cluster, Brocchi's cluster, or the coat hanger, again in Vulpecula. Useful, actually, bit of cluster this actually. If you take the cluster itself, it's got a whole gradation of star magnitudes in it. And if you want to find out what your limiting magnitude is at a particular time, you can find out by this. Just count the stars, and then you can look at a magnitude chart, and it'll tell you exactly what your limiting magnitude is. Another beautiful open cluster, Colander 70. Now, most people, I first say, who's seen Colander 70 at a club or something like that? Somebody's put his hand up. Yay, thank you, Gary. But most people, no, they don't. But you have. These are the 3 stars of Orion's belt. And Colander 70 is this beautiful cluster that is around them. This star's not part of it. This star's miles away. It's like, well, light years beyond anywhere else. And it really is lovely. It's these OB association of stars, bright, hot white, blue-white stars. And look, you've got a lovely S-shaped curve here, which I tell people, yep, so you can remember it was Steve that showed it to you folks, and it's in the sky. No. Okay, if you don't like that image, let's extend it. And we've got this swan here. It's a beautiful, of course it's not a swan, but it keeps us there. M45, Pleiades, beautiful. Just like opening a jewel box in the sky once you look at it with 10 by 50 binoculars. It's something I always get kids to find for themselves and look at, and you can tell when they've got it, oh, wow! It's like somebody's just scattered diamond dust onto black velvet or something. It's just so lovely in binoculars. And of course, most telescopes won't fit in the field of view, so you can't appreciate it anyway. Coming up to the time of year where we can see things like this. This is M24, star cloud, Sagittarius star cloud. Excuse me. And this is the densest accumulation of stars you'll find anywhere in the sky that you can get into a binocular field of view. Absolutely stunning. I don't know what it's like up there. Down here on the coast, we've had sessions where somebody said, oh, look, there's a cloud on the horizon. No, it isn't. It's this. It's this and the Scutum star cloud are both things which are absolutely lovely in binoculars. They just look so rich. Bigger binoculars, something like the Orion Nebula looks lovely as well. This is actually why I got my big binoculars. I'd seen this through somebody else's years before. I've had them for about 20 years now, but it's nice this. And you can really start seeing a lot of detail, a lot of structure, and you can spend half an hour looking at it and just see more and more and more. So I could go through loads of targets, but it would say, look at this, look at this, look at this. Really, you need to be able to start finding stuff for yourself, and it just gets boring, I think, going through a whole catalog, going through lists. So how do you do it? Well, yes, we are going to get to the self-promotion bit now. In Sky at Night Mag, I write a monthly binocular tour, mostly stuff you can see in 10 by 50s, usually 1 or 2 15 by 70 objects, things that you better off with slightly more, all in the same area of sky, and 6 at a time. And if you're getting into it, it's a good thing to do. A lot of clubs I know use it as part of their beginners program for small telescopes as well. So there's that's one thing to do. But you have to pay for this, don't you? You have to pay to get Sky at Night Mag unless you borrow somebody else's. So on my website, which is binocularsky.com, I do a monthly binocular newsletter, usually about 8 or 9 pages of what's up in the sky this month. Everything on it in the deep sky is a hyperlink which goes to something that tells you more and more about it. So there's quite a lot you can get, and the transient stuff like comets. See, here we've got Comet Swan, yeah, which is now no longer, bad luck. So I was touting this a month ago. But that's sort of nice and up to date. Right. Moving on, I hope. No, right, let's try that. Here we go. If you go onto my website, on the observing section, you can actually set up, really something I was trying to do. I was trying to teach myself how to do PHP and MySQL programming and all the rest of it, database stuff. You can set your latitude, set your horizon altitude. So if you've got gunge up to 25 degrees, you don't want to find anything like that. Set your binocular aperture if you want, or you can set your limiting magnitude of what you want to look at. You can select some more constellations, what object types you're interested in. You can even sort out the order in which it shows them to you. So that's one way of doing it. Or you can just go to, and that will give you a chart option like this, for example. Then you click on all of these, it'll take you to its page. Or you can go to an all sky chart for the month and time. And there is a key to what all these mean. So orange is open clusters and green are planetary nebulae and so on and so forth. And what you can do is if you hover over it, it won't work on the screen here, but you hover over it and it will tell you what it is, and you click on it and it will take you to an object page. So this sort of object page you get, this is Kemble's Cascade, tells you what it is, tells you what size the aperture circle is there you're looking for, tells you how to find it, which is quite useful, I hope. And then, oops, we've gone too far. It then tells you, you've got conventional find a chart and then a what you should see thing. Some of them have got it for various apertures, some of them haven't. I've got a few hundred objects in here. So I'm trying, or COVID might scupper me on this one if I'm not lucky. I'm trying to get up to about 600, but I'm still on the green side of the turf. So we're trying to get this up. So that's Kemble's Cascade again, and that lovely little cluster at the bottom, and sort of what you should see there. So this is the sort of thing you can do. If you then start getting the bug, well, there's other things you can do as well. A lot of people have said to me that they think this is the best binocular astronomy book ever written. I will certainly not sit here and contradict them. It's pretty comprehensive and probably tells you much more than you ever thought you wanted to know, and probably much more than you want to know about it. It's just much as I could about it. They wanted a second edition, so it's huge. It's got loads of objects to see in it. It tells you a heck of a lot about the binoculars itself. Or recent one, which, remember I said at the beginning, people tell you start with binoculars and don't tell you how. The idea of this one is there's 2 chapters per month, and the idea is that by looking at the objects each month, here, either taking 1 year over it or 2 years over it, you will get a familiarization with the night sky. So binoculars will familiarize you with the sky, and pick up little bits of stuff that I find interesting along the way. I think everybody should buy one of these for everybody they know and feed this sort of starving astronomer this end or something like that. But I'm sure you probably won't, but that really doesn't matter. I'll say thank you for listening, and I hope you now agree with me on that one. So thanks for listening. Thanks for letting me indulge myself, and I'd be glad to try and answer any questions if I can. So
Thank you, Steve. Now, can you stop that? Thank you very much. And I have to... Okay, so I can't see everybody at the same time today, so I'm going to have to scan through the gallery view. So, as usual, can you, if anybody's got a question, can you put your hand up? Looking all right, Phil.
Thanks, Paul. Hi, Steve. Nice to meet you. I sing your praises. I totally agree with the binoculars. I don't particularly have a telescope that's any good myself. I've always preferred binoculars. My favourites are the 8x40 RSPB binoculars. I use them for bird spotting, and I use them for basic astronomy. I've also learned to put a camera adapter onto one of my eyepieces with my iPhone, and I can track stuff like satellites or aircraft or birds and snap through my binoculars at the same time. So the multi-purpose tools for me. And like you just said, is only when I want to look at planets you really need a telescope.
Yeah.
Everything else, I'm more than happy with a pair of binoculars. And the other thing is, went on a ship last year, Greek islands, and I was on the bridge of the ship on a lilo looking at Scorpius, Sagittarius, Nepheus, and it absolutely blew me away.
Yeah.
Couldn't have done it with a telescope, no chance.
Yeah.
So absolutely brilliant. Thank you.
Okay, thank you for that, Phil. Anybody else got a question? Tony Hood. Turn on your... Okay, Tony, off you go.
Okay. You were saying it's the advantage of using binoculars is that you get a 1.4 times, well, I don't know, what was the phrase? Was it clarity or was it actual light? I would have thought it was double the light.
No, because you're putting light onto two different detectors, so you're not. Although you are getting that much more light into your head, as it were, it doesn't sum. It doesn't add up.
But how do we know this? I mean, if you go to the same place in the brain, you would think that it won't cut down one, they'll both come in, I would have thought.
Yeah, but if you look at something with one eye, it doesn't look dimmer than if you look at it with two eyes.
No, nothing to measure it with, but okay, I'll think on that. But another thing, I've got some binos that I use with my 80mm William Optics F7 scope, and I often think on that. I mean, both the eyepieces come from reception of one. I think it's about one. There's a 1.6 Barlow in it.
Yeah, so the bino viewers, yeah.
Yeah, so you're looking through one. The light coming into that one thing is split into two.
Yeah.
So it'd be interesting to find out if you were looking with a pair of binoculars, and if you could possibly compare in your own brain what you're seeing. I would think it would only be half of what you would see with a pair of binoculars with two apertures.
Yeah, because you're only getting light from one optic, from one objective into that.
Yeah.
It'll be slightly more than half, but you're splitting what light there is across two eyes. You're also passing it through a load more glass as well, so you're going to have losses in that. However, unless you're looking for really faint stuff, well, why not enjoy it? It's so much. I think most people ultimately find it so much easier to look at stuff with two eyes, which is hardly surprising because that's how we evolved.
That's how we normally operate. Yeah. I enjoy looking with the binos. Yeah.
Okay, Tony. The 1.4 would suggest to me that the two signals from either eye are being processed by the brain using something that engineers use to describe joining signals. And we use something called root mean square.
It's a square.
You square the signal, you mean it, and then you take the root. So if we just take our signal as 1 for either side, 1 squared is 1, 1 plus 1 is 2. Square root that, it comes out to be about 1.4.
Which Roy has got on his screen right now.
Square root of 1.4, yeah.
Okay, Peter Lloyd.
May I make a suggestion? The 1.4 is root 2. You've got two optics, you've got twice the area, and that's equivalent to root 2 times the radius.
Yep, it's the same. It's coming to the same thing, yes.
Right.
Yeah.
Simpler for me.
Right, okay. Has anybody else got a question? Put your hand up, give me a moment just to... Lee Osborne. Can you unmute Lee? Oh.
Yep. Hello, Steve. Very good. Thoroughly enjoyed it. I have an Orion parallelogram.
Which one?
But I have the original one.
The Paragon.
So, yeah.
Yeah.
So it doesn't have the actual bit that flips over to make it more comfortable from a chair.
Yeah.
Do you know if you can purchase that bit?
I don't think you can. I think you'd probably have to sort of get someone to make one for you.
Right.
And but the other thing with that is then I have one of the originals, which was actually the oh God, what do they call themselves? Virgo, I think they call themselves. And then Orion bought the design from them. And they don't take a heck of a lot of weight with that counterweight that's got on there. So once you start putting more stuff on the binocular end, you're going to reduce it or have to tighten up all those motions so that it doesn't sag. Okay. I think they take a bit over 2 kilos.
Right.
Yeah, a bit over 2. I think they take a bit over 2 kilos as they are. But more than that, you have to tighten everything up. Otherwise, you can't get it to sit still.
Perfect. Okay. Thank you.
Thank you, Lee. Anybody else got a question? So, anybody else got a question? And right, has anybody got a question?
No. Let's say if anyone thinks of something.
Trevor, turn on your microphone, please.
On, yeah, thanks.
Okay.
Great presentation, thank you very much. I just wondered if there's been any commercial adapters made that you can maybe screw an Astro CMOS camera onto, a pair of binoculars. I appreciate they're not going to be a flat feel like some telescopes are made to, but the big thing these days is doubling up on your hardware, and a good pair of binoculars, I guess, with 2 budget CMOS cameras on would give some people an opportunity to double the data when they're imaging.
Yeah, I mean, you're effectively doing eyepiece projection imaging if you're doing that, aren't you?
Yeah.
So, yeah. I don't know. I've never heard of it. The nearest thing to sort of trying to double up like that. There's 2. The Helios Apollos, which I showed you, they've actually got filter threads. 1.25-inch filter threads on the outside of the eyepieces, which it's not ideal, but it's better than nothing. And it's actually quite fun to put say a UHC filter or an Octane 3 filter in one side, and then you can blink from eye to eye, and so you blink planetary nebulae in and out and stuff like that, which is it's really just playing. The other thing you get is some of the bigger binoculars now have interchangeable eyepieces, and they changed them from, like my Miyuchi ones, that my big ones, onto standard size. But now the things like the APMs and that, they're standard 1 1/4 inch. So I can't see any reason you shouldn't be able to put an Astro camera onto one or both sides of one of those. I don't know if anyone's ever done it, but
thank you for that. Yeah, thanks.
Probably, but really, it's probably cheaper. Just to get 200mm telescopes and mount them in tandem than to, I don't know. I haven't looked into it, but I would imagine it would work out a bit cheaper that way.
Yeah, I was thinking of grab and go setups.
Yeah.
And you could maybe mount a pair of binoculars on a lightweight Astro tracker, something like that, to maybe go for.
It would have to be pretty light binoculars.
Yes, I appreciate it. Yeah. Okay, thanks.
Okay, anybody got a question? Any other questions? Let me just check across both my screens.
Can I make a comment on that, the last discussion? We have a member here in Doncaster who has a large pair of binoculars. I'm not sure exactly what they are, but they take standard 1 1/4 inch eyepieces.
Yeah.
So if he buys 1 eyepiece, he has to buy 2, which gets expensive.
Yeah,
but he can stick a camera in just the same as we would on a telescope.
Yeah. You also, if you're doing that, you have to make sure you're buying eyepieces from the same batch as well, because for different batches they can vary slightly.
Okay.
That's a good point. Yeah.
Yeah. Well, if anyone does sort of think of any questions, I wish I'd asked that. Please do feel free to contact me via the website or something like that. I'm more than happy to try and help people get themselves sorted out with observing with binos if they want to.
Steve, I thoroughly enjoyed your talk tonight.
Thank you, Paul.
I hope we've got your permission to put a link to your website from ours.
You do.
Thank you very much.
And thank you for doing it.
For that, we will be pointing a lot of people towards your website in the future when we say, I should be starting with binoculars, and they say, well, what should I start with? We can point them directly to your excellent material.
Thank you very much.
In the usual manner, can we give a big MSAS thank you? So just wave at the screen and